Okay, so in this video we're going to start talking about double angle and half angle identities, formulas, whatever you want to call them. And so I'm going to do a quick explanation of why we need to use these. Okay, so if I take sine of 30 degrees, you can click it on your calculator, you might know that it's equal to 1/2. Well, what happens if I double the 30 degrees? What do I equal? Well, you might think because the angle doubles, I should double my trig value. But we all know that that would be sine of 90 degrees, and don't think tripling would work. Sine of 90 degrees. So sine of 2 times 30, well, that's sine of 60 degrees, which is, oh, that's root 3 over 2. So if the angle doubles, that doesn't mean that the trig value is going to double. That's not true for sine of 60 degrees, right? So what you need to do is we have these formulas, identities that work that says, hey, if I double this angle, how is this going to change my trig value? It's not a direct proportion where if the angle doubles, so does the trig ratio. Okay? So we have a bunch of different formulas that you need to make sure that you are working with. And I'm going to go ahead and I'm actually going to derive these formulas. So go ahead, pause the video, write these down, but I'm going to show how we go from here to here, how we can go from here to here, and how we can get the alternative double angle formulas by using the initial ones that you see in the top portion. Okay? These formulas, this one right here, is not given. Okay? And this is going to be given to you, and this is going to be given to you, and this is going to be given to you. Okay? So we still might have a question where you have to actually derive the formula, make it up. Okay, so that's going to be my next slide. So pause, write these all down. These are all double angles. So it says, hey, if I double an angle, what's the new trig ratio? Okay, so here we go. We're going to derive our double angle formulas. Okay, so we have sine of 2 theta. Okay, so I'm doubling the angle. Well, sine of 2 theta is the same as sine of theta plus sine of theta, right? Adding two numbers that are the same together is the same as doubling it, right? 2 plus 2 is the same as 2 times 2. Well, I have a formula for this. Well, the formula is sine of the first one times cosine, this is what we did in the previous section, plus cosine of alpha, theta, and sine of theta. Let me shrink this a little bit because ran out of room. So that should be a theta. Okay, and we know that order of operations tells us that order doesn't matter with multiplication. The addition it does. And we should see that we have two like terms. I have sine times cosine, sine times cosine. So if this was x and this was x, you would say, oh, it's just two of these, right? So it's kind of like saying, hey, if this was xy and this was xy, that would be the same as 2xy. So I'm going to do the same exact thing. I have 2 sine of theta, cosine of theta. And that was our identity for sine. So now for cosine, we can apply the same idea, and we have cosine of theta plus theta, right? Cosine of theta plus theta. I'm going to write it in our sum and difference formula. So remember, this one's cosine, so it's cosine of theta minus now the sine of the two angles. And that gives me cosine squared theta minus sine squared theta, right? Anything times itself is a square. And here is the other primary double angle formula that we found. Okay? So now there were two other ones for cosine. Okay? So the two other ones for cosine, they're all equal to each other, so I could use any one I want. It really depends on the information that's given to us. But how do I derive those? So let's derive the other cosine double angle formulas. And I'm going to use my Pythagorean identity of sine squared theta plus cosine squared theta is equal to 1. And so what I'm going to do here is with the cosine squared theta minus sine squared theta, I can go ahead and manipulate this Pythagorean identity and use substitution. So let's go ahead and let's move sine over here. So we could have cosine squared theta is equal to 1 minus sine squared theta, or vice versa. We could have sine squared theta is equal to 1 minus cosine squared theta. Same thing, just one with the other trig function on the other side. So to find one of our guys here, I'm going to go ahead and I'm going to take this and replace it for cosine. So this is really good practice with trig identities and manipulating trigonometric expressions. And this is a minus. Okay, so how many sine squares do I have? 1 minus 2 sine squared theta. Boom. There we go. Let's do it again, but now let's replace the sine. So I'm going to go ahead and I'm going to put this in parentheses because that means that whole thing, we're going to take a sign away from that whole thing. So it's more important with the parentheses with this next one. So I'm going to go ahead and I'm going to replace sine with 1 minus cosine squared theta. And so what happens is we have to distribute the negative to both terms. And I'd get cosine squared theta minus 1 plus cosine squared theta. And so that leaves me with 2 cosine squared theta minus 1. So these are all my identities. Okay? And so I got this one right here, this one right here, and we derived them, and this one, and this one. And now the ones that are all cosine, if I'm asking for a double angle formula and we're talking about cosine, I could use any one of these and it would get me the same answer. It doesn't matter which one you use. It really depends on the information that's given. So for example, if I tell you what sine is, you could just plug it in here, boom, you got your answer. Okay, so we'll do examples with these. Remember, this guy right here, you need to know by memory. I'm going to give you the cosine ones. But I might ask you to derive them, so you need to know how to work with them. Okay, so this is our introduction to double angle formulas. We'll talk about half angle a little bit later on.